Hello and welcome back to this second part of Chapter 10, Information System Security. And we're going to start with the second question is how big is computer security problem? And so here we have a graphic from 2010 to 2014. It's more of a table than a graphic. But this lists the 6 most costliest crimes and the cost per incident and the percentage of incidents that are taking place um, with different companies. So you have the denial of service. You can see it increased, but then went down in 2014. So every time that shuts a database server down, especially on the internet, it's costing the company this amount of money, and it's happening about to 18% of the time. Malicious insiders, how often does it happen? What's the cost? Web-based attacks, malicious code, phishing and social engineering. People are trying to get in, social engineering. They may walk into your company and say they're with IT and try and trick people into giving them their credentials so they can get into the system. Then there's actually devices that walk off, and you can see when things go missing, it's costing you about $43,000 every time, and it happens about 10% of the time. So the question then becomes, as managers, how do you respond to security threats? First thing is you got to take it seriously. When somebody says change your passwords periodically, you probably ought to do that. You need to create strong passwords, passwords that aren't just words out of the dictionary or something that's identified with you with a number, because systems can find it and break that. You also don't want to use the same password for multiple accounts. Try not to send data via instant messaging or email. Make sure that when you're using a website that it's been encrypted, and so it has this protocol. If you got things on your computer that people would want to steal, try and back those up and remove them from your computer. You want to also clear your browsing history every once in a while. This gets rid of space, frees up space for you. It also gets rid of those cookies. Nice little program that can do this for you, something called CC Cleaner. You can go in there and run some cleanup steps. It'll clean up your registry. It'll clean up files that aren't necessary. It'll also look at your startup and see what programs are being installed in memory as your computer starts up, and let you know if they should be there or not, and if you want to delete them or not delete them, but maybe uncheck them so that they don't get loaded into memory until you need them. You also need to make sure you're updating your antivirus software. I know you probably don't realize this, but at school, the computer labs, they have it set up so they automatically get updated at least once a week with the latest packets, latest antivirus. And so your IT folks should be taking care of that for you, but if they're not, you need to make sure that they're doing those sort of things. And then anything you do, you should always be considering the security aspect of that business initiative. One other thing I want to point out here is that we've got, these are the personal security safeguards, but you can also have intrusion detection system, and that's a computer program that senses when another computer is trying to scan or access the computer or network you're on. I know here at Western, at the beginning of the school year, I usually can run some scans and look at my ports and see who's scanning my computer. And it's typically, the new students that come into the dorms that are scanning the network and looking for vulnerable computers that they can hack into and play with. And so, again, you need to take safeguards in order to protect yourself from those sort of things taking over your computer. So as we look at the 5 components of a system, that is, we've hardware, software, data, procedures, and people, what can we do to install or do these safeguards? So for hardware and software, we have technical safeguards in terms of identification and authorization. That is, your user ID and password. We want to make sure the data becomes encrypted. We can encrypt the data on the hard drive, so even if the hard drive were to leave the building, then people wouldn't be able to see what was on it unless they had the key, which is another piece of software that decrypts that encryption. We also want to do firewalls. Firewalls open up ports on our computer that allow certain software to send and receive information, but if the ports aren't open, then people can't come in on those other ports. And there are like 65,000 ports on a computer that different programs might be able to use. And you also have to think about how you design your application. So if you're doing any internal programming, then also think about the security that you need there. In terms of data safeguards, think you need some policies in place in terms of who has a right to see the data, edit the data, delete the data. So what responsibilities are those? Then we have also passwords here, any encryption on that data. Also think about backup and recovery of the data, and then physically securing it. You know, who has access to the rooms where these servers are running. And then in terms of procedures and people, you got to think about, are you hiring trustworthy people, training, education, so on. And so as we think about systems, think about all these safeguards in terms of security that you're going to have to manage. You also need to realize that we are connecting more and more devices to the internet. And as we have those, then there's more and more of a chance that people can hack those, take over those devices, and use them for illegal things, trying to get to those assets somewhere. So examples might be automobiles now contain wireless features. And so somebody could hack the automobile and do strange things to your car or your radio. They can also access hotel lights, any kind of thermostats, television, so on. I think recently there was an article that said that the Samsung smart TVs could be hacked in such a way that somebody could be listening to a conversation in your home without your knowledge of it. Or if it had a camera on it, someone could turn the camera on without your knowledge of it. Same thing with your phones, those smart devices. People can hack those. There's some speculation that the government has hacked those phones and they can turn them on and listen and spy on us at will. Well, if they can do it, the bad guys, other bad guys can probably do it as well. And so you need to make sure that all your devices are secure, and that if you're using them to transmit confidential information, that you don't want other people getting to that information. So question 4 is, how should organizations respond to security threats? So one is to create policies. Policies that include where should the data be stored, how will the data be processed, are you going to share it with other organizations? If so, how are you going to do that? How do your employees get access to that information? And how do they request changes to inaccurate data? This is also an issue with your own data in terms of your financial credit. You know, if you monitor your credit worthiness, then you should be able to go to a credit company and see what your score is and see what kind of data they have on you. The question is though, if they have something that's inaccurate, how can you go in there and get it changed? And so that becomes very difficult. But the same sort of thing here in your own company. If you're collecting information on a customer, and the customer sees that it's the wrong information, what's the policy and procedure for how a customer can go in and change that data that you've collected on them. Right. There's also senior management manages the risk, and so that means they need to set company-wide security policies and any kind of security function to manage those risks. So moving on, the next question is, how do technical safeguards protect against security threats? So a technical safeguard means it's looking at hardware and software components of your information system. So again, we've got this identification, authentication, your user ID and password, some form of encryption of the data. We want to use firewalls to protect, who can get in, who can get out, so to speak. So a firewall goes both ways in terms of doing protection. The malware protection, people would, if you go and you download software, it might have code written in it that does something to your computer or steals information. So you want to make sure you scan for malware every once in a while. I suspect many of you would be surprised. There's probably hundreds, if not thousands, of ad spying software that's been installed on your browser, and so you need to periodically clean that out. It speeds up your browser and also prevents people from tracking what you're viewing. The last one, designed for secure applications. All your programmers need to be instructed on how to make sure that you're not leaving yourself vulnerable for attacks. There's also this concept of a single sign-on for multiple systems. An example of not a single sign-on is when we log into the lab, we then have to turn around and log into Blackboard using the same user ID and password. While single sign-on would say, okay, once I'm into the system, then I should be able to go anywhere, sort of like the same concept of going through security at an airport. Once you're behind that security wall, then if you go to another airport, you're okay. You don't have to go through security again. So that single sign-on allows you to get into multiple systems. In terms for us, that would mean once you log into a computer in the labs, you should be able to get into Blackboard without having to provide your user ID and password again. So that gets back to the concept of making the security easy for people to use and not have to remember so many different passwords if that had been a different password. So that's another thing you can be on the lookout for. The only thing different on this side, on this slide, might be the types of encryption you may encounter. And this is the symmetric encryption, which uses one key, and then the asymmetric encryption uses two keys. There's also public key encryption, which you can use, and you may not realize this, but when you encrypt something, you need a key, and then you need to give somebody else a key to decrypt it. So what that means is you may have give out a public key so that other people can decrypt your stuff, and then you have a private key that's used to encrypt all of the information before you send it. If you don't have both keys, then they can't decrypt the information. And a key is just some information along with some characters and things that allow the data to be scrambled, and then you need somebody to unscramble it, and so there's another key that says this is how it needs to be unscrambled. And we've all played those games where you use numbers to represent letters, and then you can give out codes that way. That'd be a very simple way of encryption. So here's an example of how that might work on the web. using secure HTTP. So it has this protocol HTTPS. You see a little lock sign, and so initially your computer obtains the public key off of a website that gets sent to you. You probably don't even realize it. Your key then the computer generates a key for the symmetric encryption. Your computer then encrypts that using the website's public key, and then it sends it back. Right? And the website decodes using its private key, and it's just exactly how I explained it if you were doing email or doing something through the web. But graphically, this is the process that's going on. In terms of firewalls, you might have something like this in your local area network. So all your computers sit behind a firewall, that is, that has some kind of either hardware or software that before somebody can come in off the internet into your network, it has to pass through and check. So, you know, you might have multiple firewalls that are for different departments and so on. And so you may not even realize it, but if you have a router at home, you may have your own firewall there as well. Notice here that we have these server networks. They probably should have a firewall for them as well. In terms of malware types and spyware and adware symptoms, the things you need to look out for in terms of what may become a virus, one is a payload, and that's a program that causes some kind of unwanted activity. Could be that it deletes a program or it modifies the data and you don't even know about it. There's also spyware that's installed on your computer without your permission. It kind of loads in the background. That's why it's, again, a good idea to look at your startup programs when you turn on your computer. Make sure there's nothing there that you don't know should be loading. If not, you just stop it from loading and see if it causes any problems. If it does, then you may want to do a little more research and see if you want to allow it to load, or you may need to fix the problem that it's causing. The spyware can, monitors your activity. It can actually record your keystrokes and so on. That's also along with the malicious type of spyware. Then what I talked about earlier is you can also have adware. It may not be malicious, but it's still tracking and sending data to someone that you may not want to have that data. Chances are, if your computer's running slow, you've got some kind of malware on your system and you need to clean it. I know for my home computer, I run a system that checks everything as soon as I boot up, and it's always running in the background. It's checking all types of activity to make sure that I'm not getting anything unwanted. Probably the biggest thing you can do to safeguard yourself from malware is don't go to sites that aren't reputable. And so if you're out there downloading, TV shows or movies from unreputable sites, chances are they're sending you some kind of malware along with that software. And they're gaining access to your computer. They might even use your computer as a server to serve up more malware to somebody else. In terms of designing for secure applications, one type of attack you need to be aware of is SQL injection attack. Here the user enters a SQL statement instead of a name or other data in the address of a browser. Then once that gets in there, they try and get access to your database on your websites. And from there, they can get access to any of your data. They may modify it. They may steal it. Who knows what they're going to do with it. So here I've listed Western's website. and I typed in a search, notice that the search then gives me some information out here. It's passing code. The SQL injection means I can go in here and try and change some of these things if I knew what they meant. Or I could try and type in my own. So that's what's happening, and that's why you got to send data to other forms that you're using on your website. Not this method, but a different method, in that your programmers are trained not to send data like this that's unencrypted. So question 6 says, how can data safeguards protect against security threats? And so they protect databases and other types of data that you may have in your organization. And so 2 organizational units that are responsible for the data safeguards is the data administration. And so that's an organization-wide function that's in charge of developing policies and enforcing those standards. You should also think about, if you're going to store data in the cloud, then you're going to have safeguards there as well. And then somebody needs to maintain the encrypted keys, have a copy of those, so that you can always encrypt and decrypt your data as you're maintaining those safeguards. The next question is how can human safeguards protect against security threats? And one would be through the dissemination and enforcement. That is, somebody has to have that responsibility, accountability, and compliance. So you can't just assume that IT folks are doing all the security. Everybody needs to be involved. Your employees need to be involved. They need to know how to secure, how to make sure things stay secure. And if they don't, they need to get the training and help to do so. In terms of, what happens when somebody is terminated. Typically, if it's a friendly departure, you may not have anything to worry about, but you should have some policies in place. If somebody quits, then you immediately shut down their account so they can't enter from the outside world anymore into your place. You need to see what kind of data they were working with and transfer that to somebody else, and so on. But you don't want to do that, immediately. You don't want to walk them to the door when they say, I've got a new job. Maybe they have 2 weeks to do so. And so there's this unfriendly way. If somebody gets fired, they've done something wrong. But then again, immediately, what's the policy? You walk them to the door. The second thing is that their accounts are all frozen and audited to make sure they haven't left anything behind that's going to be destructive or do something to your data. Another area to consider is, what about people that really don't work for you, but they're vendors or partner personnel or just the public in general? How do you safeguard against those people? So you want to make sure that your vendors and partners are screening their employees properly, and that there's some kind of security training going on. If they don't need the accounts or something changes, then you want to remove those accounts as soon as possible. In terms of public users, you may want to harden your site. When we say harden your site, that is, you want to do something with your operating systems that lock down or eliminate certain features or functions that aren't required. So you may turn on certain policies that says don't allow users to be able to do these certain functions. And so that would be considered hardening the site. When we speak of account administration, these are the different things that you may be involved with. One is account management. That is the creation and modification of accounts What kind of permission should they have, and then if they're not needed anymore, make sure they get removed. What kind of policy do you have in terms of passwords? So you're going to have some kind of password management, and then you're going to have some kind of help desk policies. And one thing might be that you make sure that whoever's calling in is authenticated as a user. One thing that universities are big on is authenticating the students that are in the actual classroom. How many times have you been in the class and nobody's ever asked for your ID? They just take you at your word that you are who you say you are. And there's been examples of, other people doing whole degrees for other people, or somebody signed up an animal in all these different classes and they passed the class. So you got to make sure those sort of things aren't happening to you as well. And what I mean by that is you have people using your services that aren't part of your company, so you got to make sure you know who they are. You also want to make sure you have systems procedures in place, and so having those standardized procedures reduces the likelihood that there's going to be computer crime or some kind of malicious activity done by people inside your organization. Right? And also make sure that your system security policies are enforced. So one thing your IT people may be doing is monitoring the activity logs in terms of their servers. And so I can go in and turn that activity on and watch who's been accessing what, from what computer are they coming from, and so on, and what kind of information they may be getting. In terms of a database management system, they may be monitoring successful and failed logins. If you notice that there's a lot of failed logins, that maybe somebody's trying to hack into your database. Same thing with your web servers. We can track a lot of information there. If we turn on those capabilities of the server, and we can monitor the security information about who's coming from where. Is there people trying to break in terms of logging in different areas where they shouldn't, and being on different parts of the network. We can also monitor who's scanning what firewall ports and so on. And so that's part of this last bulleted item here. So that's part of the operating system's logs and firewall activities. Sometimes your IT folks might even create something called a honeypot, and a honeypot is they'll actually put a folder or something out there on the network that looks like it contains a lot of valuable information, and then they'll get whoever's trying to break into their system to go there and spend too much time there, and then they can trace it back to where they're at. And so it's like putting out a whole bunch of money for somebody to go and steal, and then once they try and steal it, you catch them. Well, this is the electronic version of doing something similar to that. So the 8th question is, how should organizations respond to security incidents? Again, you need to be aware of it. You need to have a plan in place should it happen. There probably needs to be some kind of centralized reporting. You need to have certain specific responses for different types of crimes. If you've been hacked, if you got stuff stolen, if it's confidential information, if it's healthcare information. You don't want to do things that are going to make it even worse and lose your credibility with your stakeholders, your customers, your employees, and so on. And so again, have a plan in place. So that plan should also include how your employees should respond to security problems, who do they need to contact, and any reports that need to be made, and any steps that you can take in order to reduce further loss or problems. Okay. You also need to be able to identify what happens if it's happens in the middle of the night. Who needs to be contacted? who needs to come in and take care of this problem. You probably don't want to wait, a couple of days later and tell your boss, hey, by the way, we got hacked. That's not a good idea. So hopefully this chapter has made you aware of the different threats to computer security that an individual can have, a business can have, and so on. What are the risks and trade-offs to that? What are some safeguards that you can put in place? How an organization should respond to those security threats? What about responding to those security incidences? And hopefully, the importance of creating and using a strong password. Personally, I have a password manager, and I generate random passwords that are 20 characters long, and it uses characters that you may not even find on your keyboard, so it'd be very difficult to crack. And I would advise you to start doing the same. And that ends this lecture.